Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where I am trying to help you to achieve your dream of getting 60 out of 60 in physics in KCET 2025 exam. So if you are someone who is preparing for KCET 2025 exam, you must watch this video. Also, we are doing one video every day. Don't miss on those videos, and every week, as you know, we are doing one important thing, that is KPL, KCET Premier League, where I am going to give you 30 questions, 30 practice questions that you can solve it during the day, and at night I will be coming back with all the solutions for those questions. And for that you have to join our WhatsApp channel. This week's KPL will be based on units and measurement, motion in a straight line, and one chapter from your second PU, which is current electricity. Okay, so these three chapters will be coming for this week's KPL. As you know, first PU chapter weightage is slightly less, but how I am going to distribute the paper will have 10 questions from units and measurement, 10 questions from motion in a straight line, and 10 questions from current electricity. Current electricity is a very important chapter, so that's why I am adding that chapter in this week's KPL. And tomorrow we will start a new chapter, but that chapter will not be considered for this week's KPL. Okay, that will be carried forward to the next week's KPL. Right? Remember that if you are watching this video for the first time, don't forget to click on the link below and download WhatsApp, then join our channel. Now let's start with the question. Today we are doing, as you know, motion in a straight line is done. Motion in a straight line's previous year questions. We are going to complete questions from this chapter. The first question is: a body is moving along a straight line with initial velocity v0 and acceleration a. The average velocity of the body over a given time interval is. So average velocity, we know that average velocity is s by t, right? So average velocity is given by total displacement divided by time. So we know that v square is equals to u square. Here u is given as v0, so I am writing v0 square plus 2as. Okay, so here I am going to find s from this equation. So s is equals to v square minus v0 square by twice of a. Now put this value here, you will get the average velocity. So average velocity is nothing but v square minus v0 square divided by 2at. So I solved this question yesterday during our lecture, so I am solving this again. If you have, in case you missed yesterday's lecture, this is from your previous question, 2023 question paper. So I hope this will help you. Now let's move on to the next question from 2022. The displacement x in meters of a particle having mass m in kilograms moving in one dimension under the action of a force. Okay, it is related to the time t in second by t equals to. So the force is moving along some displacement is acted upon by some force, and that relation between time and displacement is given by root over x plus 3. T is equal to root over x plus 3, the displacement of the particle when its velocity is 0. So very interesting question. What is the displacement, that is x, when v is equals to 0? Now nothing is given about v here, so how can we solve it? First of all, we have to separate this term x. Okay, we are trying to find displacement, so first we have to find displacement in terms of time t. This is actually wrong equation. Whenever an equation is given in this form, first thing you have to do, you have to simplify this equation such that you obtain x in terms of t, not the other way around. Okay, so first we will simplify this equation. I am doing it in step by step manner. You can do it in one step if you want. So x is equals to t minus 3 whole square. So x is equals to t square minus 2 3s are 6t plus 9. Okay, so this is the x, this is the displacement x. Now this is fine. Now what we have to do is, we have to find when the velocity is 0. So instantaneous velocity is 0. At that instant we have to find the displacement, right? Now what is instantaneous velocity? We know that instantaneous velocity is dx dt. Okay, ddx of ddt of dx, right? Whatever you are comfortable with, dx by dt, okay, ddt of x, dx dt, whatever you are comfortable with, you can just do that. So we have to differentiate this function with respect to time t. So t square becomes 2t minus 6t becomes only 6, and this is a constant, so the differentiation will give us 0, right? Now when the velocity is 0, that means this will be 0. So when the velocity is 0, this will be 0. So from there we can write that 2t equals to 6 or t equals to 3 seconds. Okay, so t equals to 3 seconds. Now what we have to do? We have to put this value of 3 here and calculate the displacement. So x equals to 3 whole square minus 6 times 3 plus 9. Okay, so 9 minus 3, 6 is 18 plus 9, so it will be 18 minus 18 equals to 0. Okay, so displacement will be 0 where velocity is 0. Interesting question. Okay, so if you make any mistakes, you will not be given any score. If you have just simply calculated t is equal to 3 seconds and you are thinking, okay, I have solved it, but I am not getting any answer, because this is only time. This is not the displacement. Displacement you have to calculate it this way, right? And only for this problem the displacement is coming out to be 0. But in some cases maybe displacement is not coming out to be 0. So you need to be careful about that. Okay. Now for a body moving along a straight line, the following VT graph is obtained. So this is a VT graph. This is given to you. Okay. This is V. This is T in case this is not clear, because it is taken directly from the question paper. Graph is obtained. According to the graph, the displacement during, okay, so they have given you this graph and they have asked you which one of them is correct. Okay, uniform acceleration is greater. Now let us understand what is happening in this process. So from, suppose this is A, this is B and this is C. Okay, now if you see the velocity is increasing from A to B. Okay, it's a straight line, right? So velocity is increasing from this to this. So here there is an acceleration, and acceleration is constant. Okay, acceleration is constant because it's a straight line. If it is increasing acceleration, the graph will be different. If it is a decreasing acceleration, graph will be different. We know that, right? But here, as you see, the graph is flat, parallel to x-axis, parallel to time axis. That means here velocity is constant, so here acceleration is 0. Okay, so here it is completely moving with uniform acceleration, uniform velocity. Okay, here it is uniform acceleration, here it is uniform velocity. Now let's see what they are saying. What are their statements? Uniform acceleration is greater than that of uniform motion. Okay, so they are asking you to find the displacement. Be careful. Okay, be careful that they are asking you to find the displacement. Displacement during uniform acceleration is greater than that of the during uniform motion. Now we know that the area under the graph represents the displacement, right? So suppose the displacement for this is d1 and for this is d2. Now first case they are saying that d1 is greater than d2. Okay, let us understand the question first. Uniform acceleration is less than that during uniform motion. So here they are saying d1 is less than that of d2. Okay, uniform acceleration is equal to during the uniform motion. So d1 equals to d2. Okay, and uniform motion it is 0. So they are saying d2 is equals to 0. Okay, so these are the 4 options that you have to be careful about. Now let us see. If you see the area, okay, both of them have equal bases, and as you can see, this part is missing in the acceleration part. Okay, this part is included in this part, so we can easily say that d2 is greater than that of d1 or d1 is less than that of d2. Okay, so these portions are equal, even though it is not maybe not appearing in the diagram. So these lengths are equal, so lengths are equal only. Here you can see that this area obviously will be less because this part is missing here, this part is not there. If this part was there, then they would have been same, but that is not there, so we can simply say that uniform acceleration is less than that of the uniform motion. Clear? Be careful when answering such questions. That may be very simple questions, but you misunderstood the question and you have answered it wrong, right? At a metro station, a girl walks up a stationary escalator in 20 seconds. If she remains stationary on the escalator, then the escalator takes her up in 30 seconds. The time taken by her to walk up the moving escalator will be. So we know that in shopping malls, in metro stations, different places, okay, even now in railway stations we have these moving stairs that are called escalators. Okay, so moving stairs. The first case, the moving stair was stopped and the girl was able to move through it in 20 seconds. Okay, she moved through this stairs in 20 seconds. So initially, suppose her average velocity is v. Okay, so average velocity of the girl, say Vg. Okay, so average velocity of the girl is Vg, and say the height of the escalator or the total distance traveled by the girl, say this is the total distance traveled, say this distance is s. Okay, so first case, how much time it took to cover this distance? 20 seconds. So we can write that s equals to Vg t. We are only considering average velocity. We are not considering gravity here because that will complicate this question. Okay, you can solve this question even without considering gravity because average velocity we are considering here. So the average velocity of the girl is Vg. So the time taken is t equals to, suppose this time is t1, equals to s by Vg, right? So we can find the time is given here 20 seconds. Basically we don't need to can consider the time here. Time is given here. Okay, so we can write that s equals to Vg times 20. Okay, so Vg is equals to s by 20, which is important. We will see. Next case is when the only escalator is moving. Okay, so let's see the average, the distance moved by the girl is same, right? In all the cases, distance moved by the girl is same. In this case, only escalator is moving, so v and the time say t2. Then again we can write that s equals to v, and here the time taken is 30 seconds. Okay, so 30 seconds. So we can see that ve equals to s by 30. Right? So we have calculated both individual velocities. Now when both are moving, the girl is moving, the escalator is moving, the total speed is basically Vg plus v. This is a very old small class problem. Okay, we have solved such questions in our 8th or 9th standard in mathematics class. So this should not be any difficulty to solve this question. Now Vg is s by 20 and ve is s by 30. Okay, now if the time taken by them say is t, then we can write that s equals to vt times t. Now here we are trying to find the time t. Okay, this time first what we will do, let me solve this. S will be common, so 30 and 20, the LCM will be 60. Okay, 60, there will be 3 plus here will be 2, so it will be s by 5 by 60. So 5 will be cancelled, 1 by 12. Okay, so 1 by 12. So now let us put this value here. S equals to s by 12 times t. S cancels, so t equals to 12 seconds. Okay, so t equals to 12 seconds. So correct answer will be 12 seconds. Okay, got it? So first what we have to do, we have to calculate individual velocities of the girl and the escalators. Then we have to find the combined velocity when they are moving together. Then once we have completed both, then we have to use the same equation third time in a row to calculate the time. Right, so only one equation is important, S equals to Vt, and from that equation you can calculate the time required when both escalator and girl is moving. Right, simple enough. Now let's move on to this question. The given graph shows, this is the given graph, okay, this is the options. So the given graph shows the variation of velocity v with position x for a particle moving along a straight line. So here how the velocity is changing. So velocity has started with some value and slowly it becomes 0. Okay. Which of the following graph shows the variation of acceleration with the position x? So as you can see that initially acceleration was supposed to be some value, and slowly it is decreasing. Acceleration is negative here. Okay, acceleration is negative, but it is increasing in the negative value. Okay, so it is increasing in the negative value. So here as you can see the velocity is decreasing, right? Velocity started with some value, say 5, okay, and slowly it becomes 0. Okay, but it is happening in a straight line, right? So velocity decreasing uniformly. So velocity is decreasing uniformly. You can do the mathematics here. I am not going into that mathematics, but velocity is decreasing uniformly. That means the acceleration here is negative, obviously, because velocity is decreasing, and because of the decreasing velocity, uniform velocity, that means acceleration should be uniform as well. So uniform acceleration should be represented by this graph. So the correct answer is option D here. Okay, so acceleration is constant over distance, okay, but it is negative in nature. So negative and in constant value, so that is only option here. Okay, so this is the correct answer. Be careful while answering this question. Now let's look into this question. A particle shows distance time curve as shown in the figure. The maximum instantaneous velocity of the particle is around the point. So here as you can see the graph is little bit curvy, okay, even though it is not super clear, but as you can see that at point R, okay, if you draw a tangent you will see that the value is maximum at point R. In any other point the value of y is negligibly small for a same time, right? So only at R the value of acceleration is maximum, because acceleration is the instantaneous velocity, not acceleration. Instantaneous velocity is given by the slope of the graph, right? So instantaneous velocity is given by slope of the distance time graph, right? So in a distance time graph, slope represents the instantaneous velocity, that is this angle. So as for small time, if the value of y is more, then we can say that slope is more, right? So this has a higher slope, this has a higher slope than this one. Okay, so this one has a very less y compared to x. So as we know that for small amount of x, if the y is more, then this will have a higher amount of slope, right? Slope is given by delta y by delta x, same as mathematics. Okay, so x is time here, y is distance here. That is the only difference. Okay, and the names are changed, names are applied to this case, whereas in mathematics they are only x, y everywhere, but in case of physics sometimes it will be distance, sometimes it will be pressure, sometimes it will be acceleration. That is the difference basically. Okay, so as you can see here the slope is maximum for R. You can check the other points as well, you can use your scale, but in the question paper it will be R. Now the question paper is not super clear in terms of the clarity. Okay, Q, R and P almost same, but as you can see it is changing here. So for that reason we can say that the slope is more at the point R. So instantaneous velocity is more at the point R only. Okay, now let's move on to the next question. A car moving with a velocity of 20 meters per second. It is stopped at a distance of 40 meters. if the same car is traveling at a double velocity, the distance traveled by it for same retardation is. So first case, what is the velocity? Velocity was initial velocity. Initial velocity is represented by u. U is 20 meter per second. So case 1, this is the case 1. Okay, from case 1 we will find the retardation, and we will apply the retardation in case 2. Okay, and the distance it traveled is 40. Okay, what is the final velocity? It is coming to a stop, means final velocity is 0. Now which equation of the kinematics we will use? The simplest one, there is no time given. Time is completely absent. So we will use only equation we know, that is without any time, that is v square minus u square minus 2s. Why minus? Because it is a retardation, it is coming to a stop, that's why we are using the negative sign. So let us put the value 0 equals to 20 square minus 2 times a, we don't know, s is given 40. Okay, so a is basically 20 square is 400 divided by, you take this on the other side and you can add this. Okay, I am skipping the step here because this is simple mathematics. So a is 5 meter per second square. Okay, now put that value into the second case. In second case, the velocity is now double. Okay, velocity is double, that means u will be 2 times 20, that is 40 meter per second. Okay, so it is 40 meter per second. Now you will use the same equation. Here you have to calculate the s. Okay, so v square equals to u square minus 2as. Here we are trying to find the s. V is 0 as usual, u is 40 whole square, and 2a is 5, same retardation. Okay, same car means same brakes means same retardation. Okay, so here s is equals to 40 square is 1600 divided by 5 to the 10, so 10, so it will be 160 meters. I have solved this question during yesterday's class. Okay, so if you have missed this class, you can check it here as well. Now let's move on to the next question. A body falls freely for 10 seconds. Its average velocity during its journey is. So take g is equal to 10 meter per second. So how can you find the average velocity when a body is falling freely? So we know that average velocity is nothing but total distance traveled or total displacement divided by t. Now it is a one dimensional motion without changing the direction. That means we can say this is a displacement as well, or distance traveled, both are same. Now we know that in case of freely falling body, okay, the displacement is ut plus half gt square. Now it is started from the rest, freely falling it is dropped. Okay, so initial speed is 0 plus half, g is 10. Okay, for 10 seconds it falls, so 10 square. So we can calculate 5 times 100, so 500. 500 is the distance traveled. Now what is the average velocity? Average velocity will be 500 divided by 10. 10 is the time, so 50 meter per second. Okay, 50 meter per second. I think the options are given incorrect here. It will be all meter per second. So the correct answer will be 50 meter per second. Okay, now as you see that object started with 0 velocity. Even though the object started with 0 velocity, it still has an average velocity. Okay, interesting, isn't it? Now let's move on to the next question. The velocity time graph for two bodies A and B are shown. Then the acceleration of A and B are in the ratio. So they have asked you to find the acceleration from this question. Okay, so what is acceleration? For a velocity time graph, this is partly deleted. Okay, velocity time graph is not there, the acceleration from the graph is not there, but I will still solve this. Maybe they will give you the question because you have learned this in your previous classes. So acceleration time, acceleration from the velocity time graph is simple. Acceleration is basically acceleration is change in velocity by time interval, right? So this is change in velocity, this is change in velocity delta v, and this is the time interval t. So basically this is nothing but slope of this graph, slope of this graph. So what is the slope of this graph? MA. Say slope of this graph is MA and slope of this graph is MB. Okay. Now what is MA? From the graph we know that from mathematics slope is nothing but tan of the angle, right? Here the angle is given 25 degrees. So MA is tan 25 degrees. Now what is MB? Here the angle is given with respect to y axis. Okay. So you cannot take the angle with y axis, you have to take the angle from here. So what is this big angle? The big angle is nothing but 90 minus 40, that is 50, right? So this is 40, so this is this angle should be 50. So this is nothing but MB is nothing but tan 50 degrees. Okay. So we can say that the ratio of their slopes is MA by MB is nothing but tan 25 degrees divided by tan 50 degrees. Okay. So their acceleration should be in the ratio. This is the acceleration. As we know, the slope is nothing but acceleration. Simple question. Tan 25 to tan 50 degree should be the answer. Okay, tan 25 to tan 50 is the answer, not tan 25 to tan 40. Don't fall in the trap. Okay, the trap is only to calculate the angle from this side. That is the only trick. Otherwise, this is a very simple, easy question. Now, a body starts from rest, moves with a constant acceleration for t seconds. It travels a distance x1 in the first half of the time and x2 in the next half of the time. Then, okay, a body starts from rest and total distance traveled, total time traveled is t. Okay, and the acceleration during his motion is constant. Okay, now so first let us see what is the x1. X1 is when it travels say up to t half t by 2 and other half t by 2. Obviously second half distance will be more because it started from the rest, so initially it will its speed will be little less, but slowly as it is going faster and faster it will cover more distance. So it is expected that second half x2 will be more. Okay, x2, this is x1, right? So read the question carefully if you have still not understood. Okay, so it is started from the rest. Okay, it moves with a constant acceleration for time t. First half of the time, not the distance, first half of the time it travelled a distance x1 and second half of the time it travels a distance x2. Okay, and then you have to find what is the relationship between x1 and x2. Okay, now let's see. First half x1 equals to half at square. So t by 2 square. This is the x1 part. Okay, initially it started from rest, so this is the first equation for x1. Now what will be x2? For x2, when you are considering this point, okay, this is not started from the zero velocity. So either you can do two things. There are two ways to calculate x2. First, you can calculate the velocity at this point and then ut plus half at square. Okay, I am not going to do that. What else you can do? You can find the total distance travel starting from this point. Okay, now out of that x1 is the first time half, right? So if you minus from total distance traveled x, suppose x, if you calculate x and then if you subtract x1, you can calculate x2 as well. So what we will do, we will calculate the total distance traveled x equals to half g t square. Total time was t, so it will be t square. Now what is x2? x2 is x minus x1. Okay, so x minus x1, let us put the value of x. X is half g. Now half g, half not g, my mistake here, it will be a. It is not falling, right? It is not falling under gravity, it is accelerating. So half a is common. if you see half a is here as well, half a is here as well. So we can take that common, and then t square minus this t by 2 whole square. T by 2 whole square means t square by 4. Okay. So now what is x2? x2 is half a, t square is common again, t square you can take common, 1 minus 1/4. Okay. So you can say that this is equals to half a t square times 3 by 4. 1 minus 1/4 is t by 4. Or you can write this as 3 common, half a t by 2 whole square. You can take this 4 back to t and make this t by 2 whole square. This is a shortcut way of doing things. So now if you see, this is equals to x1. So you can say this is equals to 3x1. Okay. So x2 is nothing but 3x1. Right. So correct answer is x2 equals to 3x1. Okay. Interesting question. Very not simple question, but you can solve this question if you know the trick. Okay. This is a slightly tricky question. Now, a car moves from A to B with a speed of 30 km per hour and from B to A with a speed of 20 km per hour. What is the average speed of the car? Very interesting. Many people, what they will do, okay, 30 plus 20 by 2. So 25. But this is a wrong method. Okay, even if the answer, final answer may be coming to 25, I am not sure, but this is a wrong answer. This is wrong method. Okay, so what you have to do, you have to use correct method. For that, first you have to assume that the distance between A and B is x. There are shortcut formulas, shortcut equations, but I am not going to teach you all the complications for this chapter because this is a simple chapter. So you can simply use basic mathematics to solve this question. You don't need to apply lot of you don't need to remember a lot of formulas to answer such questions. So suppose the distance between A and B is x. Okay, so initially it started with 30 km per hour. So how much time it took to reach for the first time? Suppose the time it takes is t1. Okay, so we can write that x equals to vt, that is 30 t hours, t1 hours. Okay, we are taking the units in hours and x in kilometers so that we don't have to convert the units. So from here we can say that t1 equals to x by 30. Right, so t1 is x by 30. Similarly, the car, while returning from B to A, it returned with the speed of 20 km per hour and say the time it took was t2. Right? By comparing this equation, I can write t2 equals to x by 20. Right? Now, what is the total distance travelled? Total distance travelled is x here, from here to here x, and from here to here another x. So the total distance travelled is x plus x. Total distance travelled is x plus x, that is 2x. Okay, so it travelled from here to here x, here to here another x. So total distance travelled is 2x. And what is the total time taken? T equals to t1 plus t2, that is equals to x by 30 plus x by 20. So x is common, 60 is the LCM. So 2 plus 3, so it will be x 5 by 60 or 1 by 12. So it will be x by 12. Okay, so time is x by 12, total distance travelled is 2x. So the average speed is s by t, that is 2x divided by x by 12. Okay, so it will be 24. Okay, x cancels. Okay, and this 12 will go up. It will be 24 km per hour, not 25. Be careful while answering this question. Okay, I know many of you will be thinking what is the difference between 25 and 24. There is a 1 km per hour difference. Right, so 1 km per hour difference, and as you see both the options are given. all the other options are very far away. This is just normal distractor, but these two are actual distractors. This one is actual distractor, where most of the people will think, okay, this is the answer to calculate average. You are not studying in class 5 where you can simply find average by like this, right? So you are now a PU2 student. You are appearing for someone maybe repeaters. So you have to be careful while answering this question. Now let's look into another easy question. An object is dropped from rest. Its speed v changes in the following form. Okay, so this is not velocity, this should be speed, because velocity is decreasing in the opposite direction. Okay, so as we have seen that the graph for velocity is like this. Okay, if you reverse this graph, you will get the speed. Basically what you are doing, you are taking the modulus of velocity. So the correct answer is this. Okay, it is a parabola. This is a parabolic path. As it is falling, okay, its velocity is increasing. Here if you see, this is also a parabola, but as you can see, as the distance is more distance is traveled, its velocity is slowly decreasing. So this is not the correct option, okay, because if you drop it as it is going towards the ground, its velocities keep on increasing because of half gt square term, half g term. Okay, so we know that v is equal to gt. Okay, as it is traveling more and more distance, okay, its velocity will increase, so the graph will be this. Okay, now let's move on to the next question. The position of a particle moving on a straight line path is given by x equal, this is similar to that problem we have solved, right? X equals to 5, but here it is directly given. Okay, so we don't need to do any headache. Okay, directly x is given, position of a straight line path, its acceleration at t equals to 2 seconds. So here we have to find the acceleration. So what is acceleration? To find acceleration, first we have to find the velocity. Velocity is dx by dt. We know that. So dx by dt, just differentiate it. So differentiating it, this is a constant, it will be 0 plus 3. Okay, this is only 1. Here it is 2, so 7 to the 14 t, right? This is velocity. Now what is acceleration? Acceleration is derivative of v dv by dt. So acceleration is, this is 0 already, this is now 0 again, plus 14. Okay, so acceleration is equals to 14 meter per second square, no matter what time it is. It is independent of time. Okay, as you can see that it is independent of time, there is no time involved here. Okay, so at t equals to 2 seconds, at t equals to 0 second, t equal to 5 seconds, no matter what time they have given, it will always be 14 meter per second because it is independent of time. Now next question, the velocity time relation of a particle starting from rest is given by v equals to kt. Now velocity is directly given, v is equal to kt. Okay, where k is 5 meter per second square, it is given. Okay, the distance traveled by the particle in 4 seconds. What is the distance traveled by the particle in 4 seconds? Very interesting question. Okay, we will use something that we have never used. What is that? First of all, at t equals to 0, what is velocity? U equals to, so v0, that is 0. Right? So if you put t equals to 0 in this equation, you can find that u is equal to 0. What else? We know that velocity is given by the equation at. Velocity is given by the equation at, where a is the acceleration. Normally when it is starting from starting from rest, its equation is given by v equals to at, right? So from comparison we can say that a is nothing but 5 meter, but even the unit is also matching, right? So k is nothing but, k is the acceleration, right? So k is nothing but acceleration. So what is the displacement formula? Displacement formula is ut plus half at square. Now u is 0, so 0 plus half, a is 5. Okay, and what is the time? Time given here is 4 seconds, so 4 whole square. Okay, so this is just a clever question, asking a easy question in a difficult way. Okay, asking a very easy question in a slightly difficult way. So it is a 40 meters. Okay, 40 meters is the answer, right? So I hope you enjoyed this question. This is a very easy question. If they have directly asked you acceleration is given by 5, then what is the displacement? I hope 99% of you would have solved it like this. But when this question is asked like this, it is a reverse thing, okay? 70 to 80% will be thinking, how can we solve it? What we have to do, we have to integrate. We have to do the integration method is fine. You can do integration and find it, but that will be very long process. Instead of doing integration, you can directly use this formula and calculate it, okay? As long as you are sure about this. Okay, otherwise you can do the integration. Those who are thinking about integration, they can do the integration and find it, but I am not going to do the integration because integration is not required here. The displacement of a particle is given by x equals to t minus 2 whole square, where x is meter, t is in second. The distance covered by the particle in first 4 seconds is. Okay, so this is a very interesting question. So they have given you x equals to t minus 2 whole square. Okay, this is a little complicated question. Okay, this is not from your KCET direct exam, but I thought this will be a very interesting question, so I kept it. And they have asked you to find the displacement in first 4 seconds, not at 4th second. If they ask you the displacement at 4th second, then what would be the answer is x will be 4 minus 2 whole square equals to 2 square, that is 4 meters. Okay, that would be the answer at 4th second. So there are 2 ways to solve it. First of all is little bit longer manual way. You have to find the displacement for each first second, second second, third second and 4th second, and then you can add them. That is one way. A second way is doing by using integration. Okay, so let's see what method we can use it here. So first we will let me divide this into parts. So it will be t square minus 2t plus 4. Okay, so this is the x. We have just baked the square. Now what we have to do, we have to find dx. Okay, dx equals to 2t dt minus 2 dt. Okay, this is 0 constant. Okay, this is a way of writing it. Now what you have to do, you have to do the integration. Okay, so integration and the limit of the integration t equals to 0 to 4. Okay, this is the thing, this is the way you have to solve this question. So dx is total integration is x equals to at time t equals to 0, x equals to 0, at time t equals to 4, it is x. So x is equals to 2 t dt, okay, 0 to 4 minus 2 integral dt 0 to 4. Okay, so it will be 2 t square by 2 0 to 4 minus 2 t 0 to 4. Okay, simple enough. Now let's solve it. So it will be 2 times t square is 4 square, 16 by 2 minus 2 times 4. Okay, 2 times 4. So it will be 16 minus 8, that is 8 meters. Okay, so as you see, if you directly put the values, the answer that you are getting is actually incorrect. The correct answer is 8 meter. Okay, you can calculate it using the second method as well. So for example, x1 will be equals to 1 minus 2 whole square, so it is 1. x2 will be, but this is a crude method, also not very accurate, 2 minus 2 whole square, that is 0, and x equals to 3 is equals to 3 minus 2 whole square equals to 1, and also you have to use it for time t equals to 0 as well. Okay, so it is a complicated method. This is not very advisable for this problem. Okay, only way to solve this particular problem is to convert this equation into a integration, and then you solve it. Okay, I hope this is not very complicated for you. If you feel this problem is little complicated, don't worry, this is slightly higher than your KCET level question, but if you are preparing for JEE exam or NEET exam, this is very common type of problems, right? So I hope you enjoyed today's session, and we have reached the end of the lecture today, and I'll be back with motion in a plane chapter tomorrow. Till then, tata, bye bye. Also, don't forget to share this channel, the video with your friends, and like, share and subscribe. I'll be back tomorrow. Thank you.